Okay, so we're looking at the zero exponent, and you can see I've skipped a few because I've called this, for whatever reason, exponent law number 6, but it falls out nicely after quotient of powers because that is one explanation as to how one can determine the value of an expression where the base, not 0, has an exponent of 0 without a reliance on a calculator. So if you recall, we looked at something such as, let's go with 2 cubed divided by 2 cubed. Well, quotient of powers tells us that, well, if we weren't sure, we could always expand it out. You'll hear me say this lots and lots. If in doubt, expand it out. So if you can't remember those exponent laws, because there's going to be a bunch of them, and it can get pretty confusing. So if you can't remember, just expand it, and you'll see what happens. So we can either look at this and have 2 over 2 is 1 over 1 and just keep going through that process until all we have is 1s, or you could have evaluated those as well and said 8 over 8. Regardless of how you look at it, it is equal to 1. At the same time, when we use our quotient of powers, we recognize that when dividing powers that have the same base, we're going to keep the base 2 and subtract the powers, 3 minus 3, and that is 2 to the 0. So that tells us then that 2 to the 0 must be equal to 1. And we can do the exact same thing with any base, the exception being 0. And the reason why is that the only way to develop this particular pattern and this rule of 2 to the 0 or anything to the 0 equals to 1 is because we have to divide by something with the same base, and it is impossible to divide by 0. So here's another way that we can develop that same rule and recognize that why the 0 exponent gives us an answer of 1. So let's pick a different base. We can use base 10. So if I said to you guys 10 squared is equal to 10 cubed divided by 10, I hope you would agree that that is 100. We continue that pattern. 10 to the 1 is 10 squared divided by 10, or 10. And so if we just continue the pattern, so you can see what's happening with my exponents, I go 2 and 1 and 0, then we've got 10 to the 1 divided by 10, and anything divided by itself is 1. And you can see right here what's happening. We're dividing by 10 each step. So 10 to the 0 is also equal to 1. And we can change up that base for anything except for 0. So clearly explain why the base cannot be 0 if the exponent is 0. So, and that is this is because dividing by 0 is undefined. And so if you were to put that into your calculator, anything divided by 0, 7 divided by 0, 0 divided by 0, your calculator will tell you that it is an error. So dividing by 0, but formally, mathematically, we call it undefined. Okay. So general rule in words is any base except 0 to the exponent 0 equals 1. So algebraically, x to the 0 equals 1, provided that x cannot equal, so not equals 0. Okay, so try that. So I'm going to hit pause again and try verifying your rule with 3 different expressions of your own. And again, see if you can break that rule. Consider, again, what is the base? So throw some variations in. Think back to the notes that we did the other day and in terms of identifying the base. So where can we have maybe that it's not really equal to the answer as a whole isn't equal to 1. And I will say this is actually something that we are not able to expand, which is why some people get confused. They often think something to 0, oh, I've got 0 of it, and therefore the answer is 0. That is incorrect. Anything to the 0, it can't be expanded, but the answer will be 1. Okay? Okay, so here are my 3 examples. One, I chose some random decimal and raised it to the exponent 0, and it is equal to, surprise, 1. Next one, a little bit trickier. So -9 or a -9 to the 0, no brackets. So when we identify the base, remember again, the base is directly below the exponent or everything in brackets. And so what is directly below the exponent is just the 9. So 9 to the 0 is then equal to 1. And then there's that negative in front, so it's almost like -1 times 1, which is then equal to -1. Next one, I've got -800, all in brackets, so that tells me that that is the base raised to the exponent 0, and that is simply 1. Excellent. So let me know if you have any questions.